Welcome everybody, I'm Mal, VK2TMF for those that don't know me. For those that do know me, I've been around here forever. So I'm going to talk about 3D printing tonight. It's a hobby that I've been interested in for a long time, but printers were always pretty unaffordable. Then Aldi started selling them last year, and then another batch of this model this year. This is actually my second printer. I've taken my first one to work, which hopefully will stay there. Ironically, the older model prints better than this one, which is kind of frustrating, but anyway. So I'm going to talk, there'll be a whole bunch of words up here. I'm only going to talk around them. The words are there so that when they eventually make it up to the website, hopefully, Jeff, that there's something to reference back to. If anyone has any questions along the way, please feel free to ask them. Now, I guess so that you're suitably distracted from me, somebody sit at the front here and start passing these things around. Somebody sit there. And you can just grab things one at a time. The verniers go with one of these.
Toss them around first together.
One of these is really good. I was calibrating the... maybe I'll use that one. Yeah, use that. Okay, go with a little box. So just, round the room, send them back. And a few of these I'm going to use for demonstrations. Right. So now that you're all not listening... Whoops, what just happened there? So that little cube that's going around is my final calibration on this at 20 millimeters, I think it is. And the wall thickness should be 0.8, which you'll find it is. So, what's 3D printing? 3D printing is an additive, can I read from here? Yes, I can. Manufacturing process, which creates an object layer by layer. It starts off with a digital 3D model on a computer. If you've been around 3D modeling, an STL file is the file type that's generally used of the 3D model. And that's fed through a program called a slicer. I use some software called Cura. Its job in life is to take the solid object and slice it into layers that the printer can then print. The output of the slicer is G-code, and if you've been around CNCs, you'll know what that is. Three main types of 3D printing. FDM, Fused Deposition Modeling, or FFF, Fused Filament Fabrication, and that's what this is. Basically, it's like a hot glue gun on an XYZ axis, squirting the hot glue in a pattern to build up the object that you're wanting to build. And the next two are optical systems using photosensitive liquid, SLA and DLP, where lasers are shone into the liquid. Where the lasers intersect, the liquid turns solid, and then the object is built up using that. Then the liquid's drained away, leaving a solid object. They're a bit more expensive, but they have become fairly readily available. And DLP is probably the more common one, uses UV curable resin. Two types of printer. There's a Delta printer, which I've got a little video of shortly, where there are three arms that intersect at the print head, and the arms are moved around to build up the object. The next kind is Cartesian, being XYZ, and that's what these are. Most of the cheaper printers are Cartesian printers. The print dimensions of this one are 200 by 200 by 180 high. So you can make fairly large objects. If you've got a long skinny object, you can place it on an angle on the print bed, and it will, so you can make slightly larger objects that way. So this is what a Delta printer looks like. Is there going to be any sound? Delta printers are much cooler to watch. I'd really like one just to watch them work. So the math involved in making the printhead move to a 0.1 millimeter resolution is pretty impressive. Most printers can't do that, build a bridge. That's pretty awesome. I don't know if it's a special material or what they've done. So they're breaking off support there. If you've got an object that is going to print in thin air, you need to support it. Okay, enough of that. So that's a... I did have a printed ball bearing with all the balls in situ. That was pretty cool. Yeah, not that one. I've got a Cartesian printer, X, Y, and Z. It's called the Cocoon Create Touch. There's a company in China called Wanhao, which makes these, and they're rebranded around the world by different distributors. The company that sold them through Aldi called them a Cocoon. They're good quality, the price is right, and there's loads of modifications and loads of support for them available on a Facebook group, or on a couple of Facebook groups, which is really active, including a group that's Australian-centric, which is quite good as well. So everything on this in blue, everything in this that's blue is extra, is something I've printed and made to improve the printer. Usually you can see there the top wobbles about just a little bit, so these Z braces are to stop it wobbling about. I've broken blades off fans by accidentally poking my fingers in, so little fan guards. The orange spool holder here. Some of the spools I've got have got very narrow centres, so I needed a smaller one, so I found a design for that and printed that. Little holder here to stop the filament getting tangled and to guide it. Loads of little enhancements that all just make tiny incremental improvements on the way that it works mechanically, improves the stability of it, and what have you. So it's kind of weird printing parts for itself. Yes.
What were they charging for?
500
Euros.
Australian dollars, all the way from Brookvale. Yeah, they didn't have many. There was a rush on them. So I'll point out a few of the parts that make up the printer. The extruder, first of all, is the mechanism here on the carriage. Like I said, it's like a hot glue gun. There's a stepping motor. I might turn that around. There's a stepping motor here on the right with a toothed wheel. Here's one I prepared earlier, somewhere here. That's some filament you can hand around. You can open that and touch that. Yeah, whippersnipper report. Here it is. So in that bag is a toothed gear, which grabs the side of the plastic and rolls it through the mechanism. And in this bag, you get to accumulate lots of little parts playing this game. You can get different size tips. The standard one's 0.4 of a millimetre, which serves the purpose very well. I haven't used this yet, but there's a 2.2 millimetre tip. It'll be very slow to print. Next part's the bed. On this one, the bed moves on the x-axis. The bed is heated. The reason the bed is heated is to help the plastic adhere to it. What can happen is if the bed's too cold, the plastic will hit it, cool, and bend and warp, and you won't get a nice flat base. That's heated to 60 degrees. I don't have one of these, but there's a Bowden tube mechanism that some printers have, and that is where the stepping motor is off to the side somewhere, and the plastic is pushed through a tube. They tend to perhaps not be quite so accurate because every time the printer starts and stops, the whole length of that filament has to be pushed and pulled and pushed and pulled and pushed and pulled. The advantage of them is that it keeps the moving mass lower if your stepping motor is not on this axis. So it's...
Does that just affect speed?
Speed and acceleration. And accuracy, because as it accelerates, it'll tend to wobble. The tooth belts here are okay. I've just ordered some steel ones to try and improve that. Some of the models you've seen around, particularly the little cubes, if you reflect the light off one of the sides, you'll find that there's sort of vertical lines on it, and that's the rubber sort of stretching and the drive belt stretching and contracting as it's accelerating.
Has anybody not seen these things?
Yeah, Jeff, once they all come back to you, put them in the box. What else have we got? Print head, we've talked about. Linear rod, not that rod, not ZZM. So there's stainless steel or hardened steel rods that all the mechanisms move on. Other printers use linear rails. Some other printers use linear rails. Filaments. There's all kinds of different filaments that you can purchase depending on what you're doing. PLA, which we'll get to, is the one that I use. The reason I use that is because it doesn't make the house smell of hot plastic, and it is also the easiest to print with. When you start using some of the more exotic materials for printing, they come with their own problems as well. ABS is a little bit harder to get to adhere and to stay flat on the print base. It'll tend to want to build up. It's got a slightly higher melting point as well. And here I've said large prints in ABS are challenging due to the high shrinkage rate, which results in warping and delamination. So if you're printing in ABS, what a lot of people do is they'll enclose their printer in a cabinet to keep the environment all at a stable temperature.
And heat it?
Sorry?
And heat the cabinet? Or bed will do that?
No, it'll heat the cupboard of its own accord. No, I'm sure it would probably help. But the bed here is sitting at 60 degrees, so that's what creates a lot of heat quite quickly. And if you've got a space of, I don't know, not big. Most people that use a box put the spool on the outside of the box, not on the inside, so it makes it quite small. Would make it a pain to get into. So that's ABS. PLA is what I mentioned before. The slide's not fitting. It's made from starch. It doesn't smell. Easy to and easy to print with. Then there's we move on to less common things. PET. As you know from drinking bottles. It's very strong, very strong and resistant to break. And there's loads of different other kinds. PVA, which you all know, PVA glue, dissolves in water. Some printers will have two print heads. The idea being that you might use two different colours, or in this case where you're perhaps printing an object that needs internal support that you couldn't break out easily. You might print the structure of the model with PLA or another solid filament, and then the support material you might print with PVA. Then you chuck the whole lot in water and the PVA dissolves away, leaving the object that that you want. High impact polystyrene, wood, believe it or not. What they do is they inject wood into the carrier plastic, and it actually does have a wood kind of texture and look to the object. It's really popular to print little baby Groots with that, from Guardians of the Galaxy. Carbon fibre. As you start getting into some of these filaments that have other stuff in them, whether it be wood or metal and things, it'll wear out the brass tip incredibly quickly. So what you do is buy a stainless steel tip. Now, I bought some stainless steel tips from China, where all good things come from. However, it wasn't very strong, the result, and I don't know why. So I bought what's called a micro-Swiss tip, which is stainless steel then coated in some special magical stuff, and it prints beautifully. So that's a delaminated print.
So how do they not the carbon fibre?
Sorry?
So how do they not the carbon fibre?
Well, they don't. It's chopped carbon fibre in a carrier, is how that works. What else is interesting there? Nylon, extremely tough. TPE, PC, metal. Metal one's interesting. We've got a roll of aluminium injected PLA at work. We haven't printed with it yet, but it's only 16% aluminium. So I'm not quite sure what the point is, because it just looks grey, like that. But I was reading the other day that somebody's come up with a process for putting 80% metal into the filament. So that has some really interesting, will have some really interesting properties, and imagine what you could do with waveguides and things like that. When you do print with that 80% stuff, you can then fire it, the plastic will burn off, leaving solid metal, which is so cool.
What are we looking at?
Yeah.
Looking at here? This has some quite thick.
It's delaminated.
So this
Each
build up layer by layer
each
by layer.
layer has not adhered to the next for some reason, and I don't know why. Yeah, but I thought it was quite cool to look at.
So that should be like a solid.
It should be solid, exactly.
You can't actually control the temperature, can you?
Yes, you can. Each material has its own properties. It'll need a different printing. It'll have a different melting point, and the print bed will require a different temperature. And you can set that as well.
The material of the tip would probably soak away heat at different rates too, wouldn't it?
It does. Brass works very, very well because it conducts heat beautifully. Stainless steel, not so well. And that may be part of the problem here, that with this delaminating, in that the very end of the tip might have been perfectly hot enough for the plastic to melt nicely, but not hot enough for it. But it might have just cooled a little bit too much as it was exiting.
So how close is the heater to the actual tip? Right?
I haven't got a close-up picture. It's right at, pretty much right on it. It's very close. Yeah, almost. So how do we end up with these objects? First of all, someone has to design them, and that's not what I'm doing tonight because I haven't learned how to yet. I've muddled my way through Fusion 360, which is the most popular design software that there is, and there seems to be the most support for it online. There's a few others, Tinkercad, FreeCAD, and OpenSCAD somebody was talking about here. OpenSCAD is interesting because it designs objects by programming, not by drawing shapes and extruding them and poking holes in them and things. Cool. You can do a lecture on that so we can learn how to do it. And then after you've got your object, you need to slice it. Simplify 3D is by far the most popular, but it does cost. Slice is another one. Cura is free. I use that. The reason I use that is it's just the model that's just the software that came with the printer, and it seems like it works well enough. Though people that have moved to Simplify 3D have said, oh wow, the printing's improved so much, so maybe I should give it a shot. There's a web link there to a bunch of different programs.
How much money are you talking about?
That's $100 or something. So all of the things you've got here, I've designed one model, and it's a little washer, a spacer, because I don't know if it's on this or not. Oh, it doesn't matter. The fit on here was really sloppy, so I made a little spacer and shim to. That's as far as I got. But there's a website called Thingiverse, which is fantastic. Anything you can imagine, somebody's already made. That's displaying in an interesting way. There we go. Is there a search button? Should be.
Question, Mel.
Mm.
Do you make things as good as like a screw thread?
Yes.
Like a fine screw
Well, there's one there. So is that about 1 mil pitch? 1.25 pitch? Anything finer than that, you can tap pretty well anyway. But yes, it'll do a screw thread. This is for Dom's benefit. And now that Dom's here, here's the centerpiece for the dipole you were asking about. And some egg insulators. Use the metal stuff, yeah. So Thingiverse is a fantastic thing.
That's the next question. Are you going to be able to print a piston for your car if you're in the middle of the desert, or are you going to?
Not with us. Not with us. You're not.
But where's the technology going to go?
There's a lot of emphasis at the moment on metal printing. There's already been using like a MIG welder on an arm to build up things. There's been filament with a high content of metal. That's been quite an achievement. There's also other methods of printing metal as well by sintering. So you have a very fine layer of the metal, and a laser melts a layer. Then you put another layer of the powder on, and you laser the next level, and you build up the object that way.
But all printed an entire engine block.
Who did?
CSRO.
Oh, really? Using what technique?
1908, one-of-a-kind car that blew up. And they printed it in sand and tipped out the sand and took the sand cast down a custom made.
Okay. Oh, cool.
Conventional metal casting, but the mold was 3D printed.
Cool. Yeah, of course. It's the only way to. There was no original motor left, I guess.
Yeah,
or.
they had to take the motor apart and scan the whole thing.
There are a lot of potential medical applications too.
Yes, I've heard of it.
The press recently about them doing the liver, and others have worked on kidney, and so organs that require some sort of structure with them. You can print the framework of that, and then actually print cells, spew out the kidneys and
That's impressive. Print cells.
well, yes,
Yeah.
so just taking sort of plastic kidney cells, liver cells.
It depends on what's on your spool on the day. Today I'll make some ears. Blue ears, I hope they're okay.
Does that stuff break down under UV?
Yes, it does. One of the materials in the presentation, I forget which one, is UV stable.
And that's easy to work with too?
I haven't tried to use it yet. I hope so. Because I've got some stuff for work I need to print that's UV stabilised. PET is? Okay. There was another one I mentioned somewhere there. Anyone see the word UV? ABS is not, but you can get it that is. Now, I thought I made special note of one somewhere that was UV stable. There it is, ASA. I don't know anything about it yet, but I have to go and do some research and see if I can buy a roll and start experimenting with it. And hopefully it doesn't stink the house or the office out too much. Yeah. Okay, so that was kind of brief. Any questions? Yeah, I thought you'd be waiting for that. Yes, the sundial. I'll talk about some of the things I made, I suppose. NASA was interested in 3D printing in space, Am I still in the frame? I think I am. And they took a 3D printer to space, and they emailed a ratchet to space for them to print, because they, the idea was you don't have the tool that you need to undo the bolt on the solar panels or whatever, so we'll send you a design and you can print it there. And that's the design they sent to space and printed.
They need to set up the machine that recycles back into filament after they use it too.
Sorry, they what?
You need to set up the machine that recycles the spanner back into filament.
Oh, really? Yeah. You got to provide the socket. Just a few things I'll point out. This is a part that broke off of this printer, actually. I reprinted them grey. But what happened was something happened to the material as it was printing. It got jammed, or I don't know what. Anyway, there was a weak layer. And that's the trouble with a layered thing, is that it's weak in that axis. But what you can see there beautifully is the infill, the honeycomb infill. You can print various densities of infill from none to 100% if you want a completely solid object. So I think in the end I printed some of these extra parts in 100% infill, just so that I knew they were solid. What else have I got here that's kind of interesting?
A lot of these plastics, the polymer molecules are so long, the action of squeezing them out actually aligns them all along the extruded fibre, so you're actually laying molecules lengthways.
Okay.
So it's not just the adhesion that's an issue, but PET is different in soft drink bottles versus in mineral water bottles, because it's expanded a certain way to make them stuff like plywood at a molecular level.
All right.
Whereas the soft drink, the non-pressurized bottles don't need to be done like that, and they're made differently.
Okay, yeah, I've seen the blanks from soft drink bottles where they're blown.
And these can only, so soft drink bottles are expanded lengthways and then expanded sideways, and that makes the molecules lengthen and then expand like plywood.
Right.
Whereas they don't do that with the mineral water bottles.
Okay. I did a tolerance test on the printer. Like I said, the old one's a bit better. This is from the old one. But this was printed with little slugs, I guess you'd call them, spaced at different spacings from the inner perimeter of the ring. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 millimetres. So the one that got stuck in there, and you can't get out, is the 0.1, which means it's good to about 0.2 of a millimetre.
So you can also mail out the design and have it, have it manufactured with high quality
you can.
machines. Like, do you have any sense of where?
Yeah.
You just email
VK2TMF. The Seed Studio, who's more known for circuit boards in China, and there's loads of other places as well. You can email your design to pay them some money, they'll print it and they'll send it back from various materials that you specify. There's also a website. I haven't signed up for it, and I probably should, but I can sign up to it and say, hey, I've got a 3D printer, here are my costs. And anybody else can find you on the website and send you the design, and you make some pocket money with it.
I'm holding a dipole then. Is that what happened here, or did you write the program to do this, or was it on Thingiverse, or what?
It was off Thingiverse.
Yeah, okay.
Yeah, I haven't learned to design things 3D
Well,
sufficiently to demonstrate it.
Have you got next month?
No, actually, Clifford's just volunteered to do OpenSCAD. Yes, Dom.
In the circuit board world, when we're really worried about a circuit board, we might build in a part of it which you can test afterwards, like an impedance control line that's not actually part of the main circuit, to see how well you're etching, wet, and all that sort of thing. I wonder if one of the weaknesses here is the Z-axis connection that you've got between the layers. Maybe when you're printing an object, maybe you could also print a blank off the side, just a column, and that column could be stress tested afterwards to work out how well the bonding went.
Right.
And then you know.
Oh yeah, print them both at the same time.
Your model is actually up to speed.
Yeah. I'll just find something I can sacrifice. This will do. So that's printed from PLA. The layers go this way, I'll try and break it on the thin axis. Okay, I'll break it on the thin axis. Anyway, you get the point. It's pretty strong. Think. I don't mind if that breaks. I don't really need it. So, where was I? Any more questions before I start making something?
So, man, again, this dipole setup.
Yes.
I'm just assuming that
You want that, don't you?
I like thinking. But if you wanted it twice as thick, it would just be a matter of going and changing that part of the program if you knew what you were doing and press the start button again, and it would be bigger and stronger for 160 metre dipole.
Yeah, you'd load the design into your 3D printing software, 3D creation software, design software. That is a yeah, it's an STL. And then using that, you could, stretch it in the Z-axis and make it fatter. Or that one's got infill, I think. You can see the honeycomb within it. But you'd ideally want to print that solid.
I see, you mean the guts of it you do as honeycomb?
Yeah.
Material.
Yeah, that's right.
And so what's the cost in materials to print something like that?
$1, $2, not much. These are a kilo rolls, and they're about $33 a roll is what I paid for on special.
So at what point is it worth actually making a mould and doing an injection mould compared to pumping them out of the stock?
I don't know. What's an injection mould? A couple of grand maybe for something like that?
Oh, yeah.
For the tool, $4 grand? I don't know.
In Australia, $4 grand, overseas, $500.
Yeah, there you go. It depends on speed, and I don't know what the break even is. But the time that it takes to print these, that might have taken an hour and a half or 2 hours. In a working day, you're only going to print 3, so, or 4.
But it could take you 6 weeks to get your first mould.
Yeah, that's true.
Can you print circuit boards that are conductive?
Perhaps with that really trick filament I was telling you about. Perhaps if you had a two-head printer where you could print insulator and conductor side by side, but yeah, not really.
There are inkjet frames for conductive inkjet.
Yeah.
Can't have solid food.
Yeah. Yeah.
So in practice, where do you get your consumables from now?
There's loads of shops in Australia that sell it. JCar sell it anyway because they sell 3D printers. Don't buy a JCar one until they start selling spare parts. The JCar designs are actually pinched off Chinese websites anyway, so you could probably buy parts that'll work from AliExpress or eBay, but just a word of warning. Oh yeah. But yeah, I just buy them online. The company that sells the printer sells the filament as well, but they're a bit pricey. There's a website called 3D Phillies, which everybody says to buy stuff from, but because it's a really popular hobby at the moment, it's sometimes there's stock is a bit low. But you can buy it from AliExpress or eBay and wherever. And all of the little mechanical parts, some of the ones I've sent around, like the hot end and heater elements and fans and rods and bearings and threaded, there's a name for them and I can't remember it. The threaded part, anyway. Threaded rods and the nuts that go on them. You can buy them all from eBay just for a couple of bucks for just about anything that you want to replace on it. Or if it's under warranty, just get it from the manufacturer, 12 months.
Many of the extruders have two things on both sides. I saw that one had a smooth wheel and a toothed wheel.
Yeah, it does have. I've never seen one with toothed on both sides. That would be interesting.
But they do have some problem with grip, I believe.
Yeah, the grip is generally okay as long as your print head's, as long as the filament is melted enough to push through the extruder. Where it gets a bit tricky is when one of the filaments you can get is flexible filament. So you might want to make a phone case or just something rubbery, a spider or something, I don't know. And the difficulty there is that when the stepping motor pushes the flexible filament, instead of going out the print head, it tends to want to go sideways and jam things up. I have a roll of that I was not very successful with, but I subsequently read and seen some YouTubes on how best to to set the machine up to do that filament. I think once you get a filament going, all good, you can start making really nice models, as most of the ones you've seen are. Then you'll change filaments to try something else like PET or ABS or whatever, and then the whole learning process starts again. You've got to get the temperature right, the feed rate right, the print speed right, the cooling right. There's many, many variables, which brings me on to this. It's a little calibration thing that I made. I didn't make it, somebody else made it, but I injected some extra G-code into the file to say, start the base at, what does it say, 200 and, oh, I can't remember what it was. It says 210 here, but it probably wasn't. 210 degrees, 220, 230, 240, 250, 260, 270, to find the ideal print temperature for the filament I'm using. So you can see there's, well, those with good eyes, there's kind of stringy little dags in the lower portion, and where it was too hot, there's a kind of hair drawn between the pillars. And the sweet spot for this was about, oh, it was cooling as it goes up, that's right. So it started high, 240, 230, 220. I can just read it on the side of here. 210, 200. So the ideal print temperature for this is somewhere between 200 and 220. You can pass that one around.
Just make a great big table for next time.
Sorry?
Make a great big table for next time. This thing, this rate, this thing.
Yeah, in a perfect world, it would be really neat to be able to have some object that'll test temperature, print speed, all sorts of different variables all at once until you can hone in what you're doing.
But would you expect to be able to translate your findings on that to another machine?
Yes, an STL file is universal.
No, I'm not in the settings for the temperature.
Oh, okay.
Somebody's got
Yeah.
all of that and saying, oh, what should I use
Yep.
for this? Same machine.
Yep.
That should work.
Even on a different machine, it's the material that's the important part. Different kind of machine. So let's print something. So what it's doing presently is just getting up to temperature.
In 40 years' time, I sat there with Mal and had one of these.
We should use that at Joda.
It's going to be the same scenario.
So there it's zeroing its there's micro switches on each axis that determine the 0 point. Hopefully it hasn't bumped while it's been in the car and carried around.
We're going to keep some suspense about what we're printing. We've got the S. No, don't tell us.
No. Okay, I won't.
Bob's going to know.
This is much fun as watching the old HP plot.
Yeah. 500. It's printing a just a dummy border to try and clear the nozzle and make sure it's printing nicely, and then it starts working. Absolutely. It's not too hard. This has got a little wizard that'll move the print head to here, to here, to here, to here, and you use a piece of paper as a feeler gauge. As soon as you feel much resistance on the paper, you know that it's set about right. It wants a gap of about 0.1 millimeters. Yeah, but you've got to adjust these thumb wheels. There's 4 thumb wheels on the bed. Yeah. So even if I had a Z probe, which people do, if the bed's wonky, you'll still end up with a wonky base. So that's printing away. What I will do, yeah, pretty much. We can have a little bit of fun. This is what I did the other day, actually, for one of the models that I've handed around. I sped it up 300% to see if it would work, and it did. Actually, it jammed for some reason the nozzle got blocked 3 times the other day. So what it's doing now is the first layer. First layer is the most critical to a successful print. If the first layer's crap, then it's then the rest may not work very well. No, you can. You can. So what So that's my, any other questions, and then people can just watch it work. It's a bit of a pain. You undo a couple of unscrews, the stepping motor comes off the right, the heat sink and stuff comes off the left. You heat it up, pull the filament out, eyeball it, have a look, try and push the filament back down in, see if you can figure out why it jammed in the first place. Put it all back together and try again.
You don't know where it's up to, or you've got to start over?
You start over. So I've just sped that up 300%, so it's going 3 times the speed it was before. That's as fast as it'll go.
It's got the lower temperature at the top where the bits moves across the thread.
Yes.
So it's too low, so I'll have to get tools right there.
Yeah, it was too low, so it was causing stringing for whatever reason. And when it was too... Oh, that was interesting.
And the printer, how much power does that thing take?
Oh, I don't know. Yeah, that'd ruin your day if you're 90% the way through a 2-day print. And the longest print I ever did, I think, was that one.
What came back a week later than me with the box?
It was about 2 days or 2.5 days.
Then he came back afterwards and went, whoa, wow.
Still going.
Oh, okay. You know what that is, don't you, Russ? Which one?
I wonder if we can make this work. Anyone know how to make Eve's little camera work?
You know what that is, Russ, don't you?
Oh, yeah. Star Wars thing.
What does that plug into?
A Star Wars thing. May the force be with you, Russ.
The one that impressed me, and I bet everyone doesn't know what it is, was the sundial.
Oop, that won't fall any further.
See, someone's been playing with it.
Well, that's not going anywhere.
That's the trouble. Kids play with them and they break them. Has it taken another 2 days to print another one?
Anyone know how to hook the video up to this?
We need these.
Eve! Eve! He's not here, is he? Is there an RCA plug in the back of that projector? I'm wanting to... Okay. So now all I need to do is find the other end. What's that?
Metal plug on the end of the cable.
This might be it here. It was plugged into the DVD or something.
Sounds about right.
Yeah, that'll be it.
Yep, that's it. Power on the camera. It's probably when you change the short saver somehow.
Yeah. So what I'll do is I'll unplug my laptop and maybe it'll just figure it out. Okay. How do I know if it's on? There we go. Everyone getting motion sick? Maybe this end.
Had it right and then you got to go and play with it.
Huh. There we go.
They make a star on it.
There you go. Now you can watch it.
Come back tomorrow, we've got Barbie.
I have a there's a program called Octopi, which runs on a Raspberry Pi, funnily enough, and it plugs into the USB port of this. So what that allows you to do, instead of having to copy your file to the SD card, come out to the printer, plug it in, away you go. You can send the G-code file to the Raspberry Pi, which will automatically then start warming up the printer and then start printing straight away. That software also has webcam streaming software in it too, so you can see the progress of your print. So the only thing you need to do really is come out, change the filament, and remove the remove your printed object when you're ready. So I use that. I could VPN when I was doing a long print. I VPN into my home from work. Brought up Octopi. I could see that it was still working, and I could see the picture that it was still working fine.
Have you heard of anyone doing a printer using UV resin?
Yes, that was one of the methods in the slides.
No, I don't mean in a tank. I mean actually extruding the resin and following it around with UV LEDs and cures it.
No.
After laying it down.
No, I haven't. That'll be interesting.
No, it's fine.
So the printhead temperature is 215 degrees for this. Unfortunately, the filament is absorbs water. So some of my older filaments you print, and you hear it going pop, 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 and there's little blisters on the surface of what you're printing, which weakens it, unfortunately.
Can you pre-cook your filament?
Yeah, you can.
Stick it in the oven for
Yeah,
45 degrees for an hour.
yeah, people do that. Yeah, it's been done.
No, it doesn't mean that.
Take the reel, put it in the oven, low temperature,
Don't melt it, just get it warmer.
Yeah, I'll keep it in our data center at work. So yeah. Point eight. Point. I don't know. Go ahead.
So are these essentially thermoplastics or are they thermostatic?
They are thermoplastics.
So you get up to temperature and it'll melt again. And
Yep. Yeah, the wall thickness on these is about 0.8. I don't know if that's 2 layers or 1. 0.4. I thought I had one of my samples down to 0.4, but I can't find it.
What are you printing then? One of those turn around like this.
I thought it was broke.
There's some prints where it didn't adhere properly to the print bed. You can see one of the little legs of the egg. No, it was kind of like spaghetti underneath it. Yeah, I can't remember what infill I used. They are. Can make them solid, just takes longer. Okay, why don't you come and take a closer look if you'd like while it's working. That's it for the night. Thank you.